The current wildfire season is causing a flurry of firenadoes, pillars of flame that emerge from the blaze. Are these strange firewalls occurring more frequently this year due to the weather? You can attribute the increase of firenadoes to the arid conditions in the western United States. However, it's also possible that more smartphones are being used to record them. NBC News spoke with Bret Butler, a research mechanical engineer at the Missoula Fire Sciences Laboratory of the U.S. Forest Service. "I think when people saw them in the past, they just said, 'Wow,'" Butler said. "They are impressive as long as no one gets hurt." As part of the Missoula Lab's Fire, Fuel and Smoke Research Program, Butler and his co-workers investigate firewalls from less than 3 feet 1 meter in diameter to 2 miles 3 kilometers in diameter and 3 miles 5 kilometers in height. The blazing twisters can vary in size. More than 110 miles per hour, 50 meters per second tornado-level winds are capable of whipping about. The Great Tokyo Fire of 1923, the deadliest firestorm ever recorded, claimed the lives of more than 38,000 people in less than 15 minutes. According to the lab's website, a 300-foot-tall firenado struck a throng of 44,000 people who were gathered at an unoccupied area of ground near the river during Japan's Great Kanto earthquake in 1923, as more than 100 uncontrolled fires swept through the city as a result of the earthquake. 300 people were left. Fire departments had a difficult time putting out the fire because of earthquake damage. 45% of Tokyo was destroyed by the firenado and other fires before they were put out. During the World War II bombardment of Hamburg, Dresden, and Hiroshima, more enormous whirls were produced. Butler stated that they were largely constructed as a result of the terrain and how the city's structures were arranged. A powerful wildfire producing superheated air that rises quickly in the presence of light to moderate winds is what is most likely to cause a firenado. The winds merge into the fire, creating a vortex that resembles a tornado. John Erdman of the Weather Channel compares it to how ice skaters accelerate their spins by drawing their arms inward. Extreme droughts like the ones we've been experiencing this season in Nebraska, Kansas, Oklahoma, Texas, New Mexico, and Oregon can encourage stronger firenadoes. In a 2008 fact sheet about the phenomena, former California firefighter Royal Burnett said that the faster the fuels burn and release energy, the drier they must be. Mechanical engineer Jason Forthofer at the Missoula Fire Lab stated in a report that if there is anything that causes more intense fire behavior, the odds of having a firewall go up. Forthofer claimed that a mountain's lee side, or the side that faces away from the wind and where the air can become turbulent, is where firewalls are also more prone to occur. Fire tornadoes against firewalls. According to some research, fire tornadoes are real tornadoes that form through a process known as pyrotornadogenesis while firewalls remain anchored to the ground. They lift off the earth and secure themselves to a storm cloud. These twisters are extremely deadly in either case. According to the Missoula Fire Lab, they are capable of uprooting trees, toppling cars, and ripping the roofs off of homes, damage comparable to that caused by an F2 tornado. How are they formed? A big area of extremely hot air produced by a wildfire mixes with cooler air that is located higher in the atmosphere to create this natural site. A similar atmospheric instability to that which produces other spinning air phenomenal dust devils results from the interaction of updrafts and downdrafts. It is only burning in this instance. While firewalls normally disappear after a few minutes, more uncommon fire tornadoes have the ability to draw heat upwards and combine with atmospheric moisture, resulting in the development of pyrocumulonimbus storms and the emission of smoke into the stratosphere. The primary goal of the Missoula Fire Lab's research on firenadoes is to effectively advise firefighters battling wildfires. However, smartphone-wielding witnesses could also benefit from the lab's recommendations. Don't just stand there and watch a massive fire, Butler said. On the order of 100 feet, you need to warn everyone nearby, then back off. How often do firenadoes occur? This phenomenon is not new, even though we may not see these fire tornadoes very frequently. The use of cell phones has made it much simpler to record firenadoes in the US southwestern regions, including Arizona, California, Colorado, New Mexico, and other states. There have been reports of fire tornadoes in recent years. In reality, the National Weather Service issued its first ever fire tornado warning in 2020 as a result of one of at least 5 firenadoes that were observed in California that year. Climate technology advancements, such as the use of satellite and radar data, improve our capacity to recognize topography, climatic, and vortex variables that could lead to the creation of firenadoes. As a result, population centers that may be in the path of dangerous fire whirls can be warned in advance by early warning systems. A well-known firenado tale you may have heard. A horrific video shot by firefighters that was part of the Northern California tenant fire in June 2021, which destroyed over 10,000 acres of property, quickly became popular online. The video, which was shared on Facebook, depicts the enormous size of a giant firenado as it approaches fire teams and large gear trying to put out the dramatic occurrence. It is swirling with red luminous smoke. Are tornadoes getting worse because of climate change? Firenadoes could become more dangerous as a result of climate change, which runs the risk of making wildfire seasons worse. For instance, researchers believe that southern Australia could experience an increase in the likelihood of fire tornadoes due to changes in extreme weather. Droughts brought on by the increasingly frequent heat waves can give fires more fuel to burn and make it easier for them to start. Climate change may not directly increase the frequency and power of firenadoes, but it is possible that it will contribute to the conditions that encourage them. However, understanding the factors that lead to the onset and spread of wildfires allows us to forecast severe heat events, which helps people and organizations better prepare for wildfires and firenadoes before they begin or during their early stages. Firenado effects on health. Affected areas are always at significant risk for health problems due to smoke pollution from wildfires. Likewise, wildfire pollution has the ability to disperse widely and can even occasionally transcend entire nations and oceans, deteriorating the air quality in far-off areas. When compared to equivalent particles from other sources, wildfire-specific PM 2.5 pollution was found to have a greater adverse effect on health, with a daily increase of 10 grams per cubic meter leading to a 10% increase in respiratory hospitalizations as opposed to a daily increase of 0.67 to 1.3% with non-wildfire PM 2.5 pollution. Although everyone's health is at risk from wildfire smoke, those with chronic respiratory and heart conditions, children, the elderly, and those with asthma are particularly at risk and need additional safeguards against its harmful effects. It used to be more challenging to record fire whirl tornadoes since they frequently occur in isolated locations. In spite of the fact that professionals can now safely mimic actual fire tornadoes in a unique lab chamber, it is still quite challenging to put out a fire like this in the real world. As soon as a fire starts, Julie Malingovsky, a meteorologist with the National Weather Service, said, "Everything the fire does in terms of spreading depends on what the weather is doing around it." Having said that, we hope this episode spreads awareness to everyone. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world. And don't forget to like today's video. We'll see you in the next video. Thanks for watching.